In this video, we're going to be discussing the ideas behind matrix multiplication, which is, if you ask me, every year that I teach these, probably one of the more frustrating things that students are, required to do. But once you get it, you get it. I mean, it's not that bad. But let's start by understanding it. So what I'm doing is I'm saying let there exist two matrices, A and B. But you notice here I've given their orders. Okay, so A is an M by N matrix, and B is an N by P. But let's go ahead and start with this. Matrix multiplication is very, very interesting in that it is only defined if, and in order matters with matrix multiplication, but only if these middle two dimensions, when you stack them side by side, if those middle two dimensions are the same. Okay, so these are the same. That is the only time we are allowed to do matrix multiplication. So here's a good thought. If you have a math teacher and they're asking you to multiply two matrices and those two inside numbers don't match, you can just say, I'm done, because you can't do it. Okay, it's not possible. And the interesting thing is we actually end up with a solution, and I can tell you right now we say some matrix C. So if we were to say A times B, so we got an M by N, an N by P, and since these two inner dimensions match, we say we get some new matrix C, but the interesting thing is C, I can tell you right now, is going to be an M by P. And you might be saying, okay, well, where did he get these numbers? And actually, the neat thing about it is this. If the two inner dimensions match, then we can say the new matrix that we get has to have the dimensions of these outer two dimensions. And this is just purely the case every single time that matrix multiplication is defined. And so, let's make an assumption. What if we assume in this instance that M and P are not the same? Then, okay, it follows that if we were to try to do B times A, we would say then this would be undefined. Undefined. You could not find their product, and the reason why is because we've got an N by P times an M by N, okay? And the fact of the matter is these two inner dimensions, they're not the same. So we cannot do this, okay? So let's talk about how does one find a matrix product. It's a really, really actually interesting process here. So let's let us define a couple of square matrices. Nothing wrong with square matrices. It's just they're easy to deal with. So we say 2 by 2, and we'll go with some simple values here. How about 1, 0, negative 2, 3? I like those numbers. And we'll let B be a 2 by 2. That was kind of sloppy. A 2 by 2. And why don't we call B? We'll throw a 1 in here. 1. How about a negative 1 here? We need a 0 because it's easy to deal with. And a 4. Nothing wrong with these two matrices. Okay. So what we're interested in finding is the product of A times B. Okay. So first thing we want to notice is this. So we get a 2 by 2 times a 2 by 2 that our inner dimensions do actually match, okay? And so since these match, we say then it is defined, and also that we're going to get some new matrix that has the outer two dimensions as its dimensions. So we're going to get some C that is a 2 by 2. So what I would like to do is I'd like to go ahead and write this out in roster notation. So we had 1, negative 2, 0, 3, and this is in a product with 4, 1, negative 1, 0. And we know that we're going to get some new matrix here that is a 2 by 2. Now I'm going to elongate this quite a bit. 2 by 2. And there's a reason behind it because I'm going to put my work in here. But we're going to get some matrix here that has 2 rows, 2 columns. Okay. So let the fun begin. Okay. So now, because we're taking a 2 by 2 times a 2 by 2, and we're going to get a 2 by 2 for an answer, okay, we know all of this is defined. But we always, when we talk about matrices, we always refer to rows before columns. You know, when we give an order, say M by P, okay? So, we always give rows first and then columns. When you do a matrix product, I want you to get this idea in your head that the first matrix here is going to be like our row giver, whereas our second matrix is kind of our column giver. Now, this is just my mental construct that has worked for me in my lifetime, but we're going to be referring to the rows in matrix 1 and the columns in matrix 2. But here's how this is going to work, okay? So, for example, we want to find now this new C that happens to be in the first row in the first column. So since we need the entry here in the first row, first column, what we're going to do is we're going to go back to the original matrices here, and let's make this really clear. I don't know if we went like bright green, okay? We're going to refer to the first row here in the first matrix in the first column in the second matrix, okay? And here's how this works. We're going to start with the first entry here and the first entry here. We're going to multiply those, and we get 4. Okay, so that 4 is going to go here. And we're going to take that, we're going to add it on to, and we're just going to keep going right down the row. So we go to the next entry on that row and the next entry in that column, and we multiply those, okay? So -2 times -1 is +2, and we get 2. Now, we would add on more, it's just that we've run out of elements in this row over here, in this column right here. Okay, but there should always be as many elements in that row as there are in that column, and that was given by the fact that we made sure these inner dimensions matched. Okay, and so we come over here to our matrix, and we end up with, let's go back to white. We end up with this term in our solution, our product, that is 6. Okay, so let's chase after another one here. Let's say we go after here, and so this would be C row 2, column 1. We're going to mentally highlight row 2, mentally highlight column 1, and we're going to go through element by element and say, okay, so 0 times 4 is 0, plus 3 times -1 is -3, so we get 0 plus -3 is -3. Let's go after this guy here, which would be C row 1, column 2, that element C1, 2. So we say row 1, it's in row 1, so we're going to mentally refer to row 1, and then mentally refer to column 2. And we say, okay, so 1 times 1 is 1, plus, we'll add that to whatever we get when we take -2 times 0, which is 0. So this comes out to be 1. And then last but not least, we say, okay, so this element here, it would be C22. Second row, so we say second row, second column, and we'll go through. We say 0 times 1 is 0, plus 3 times 0 is 0. We get 0. And so this would be our product matrix, okay? So interesting that that's the way we kind of carry out multiplication. Let's try to squeeze maybe another one in here. They get a little weird looking sometimes, and people are like, can we really do this? So I'll try to write smaller here. Let's go A, and this time we'll let A be a 2 by 3. So 2 by 3. So rectangular, definitely. We got, how about 1, 2, 0, -1, smaller numbers with examples always work nice. And then we'll let B, so B I want to be a 3 by 2. 3 rows, 2 columns. Okay, so rectangular in a different fashion. How about -2, 4, we'll throw in some 1s and 0s. How about lots of 1s and 0s? I'm cool with that. So let's say we wanted to take A times B. So again, first let's notice this. A 2 by 3, in a product with B, a 3 by 2. We know that the inner dimensions match, so this is kosher, it's cool. And we're also going to get a new matrix C, and C has to be a 2 by 2 judging by these outer dimensions, okay? And so I'm going to go ahead and I'm going to write our C matrix here, and I know it's going to be a 2 by 2, so I'm just going to go ahead and say 2 by 2, here are our entries, we'll just work on filling these in. But I know I'm going to get a 2 by 2. So let's go ahead and we say A times B. A is on the left of B, so we say it's our row matrix. We refer to row 1, column 1, in order to get our row 1, column 1 entry down here. So let's go ahead and work through this. We say 1 times -2 is -2. We'll do our work over here. -2. 0 times 1 is 0, so plus 0. 3 times -1 is -3. So this entry comes out to be -5. How about we'll go after this one down here. Row 2, column 2. So we say row 2 on our first matrix, column 2 on our second. So 2 times 4 is 8. -1 times 0 is 0, of course. And then -2 times +1 is -2. We get 6. How about we'll go after row 2, column 1. So we got row 2 over here. Row 2. That's a 2 right there. I'm just making it worse, aren't I? There we go. That's a little bit better. Row 2, column 1. So we end up with 2 times -2 is -4. Negative 1 times 1, negative 1 plus, and we got negative 2 times negative 1 is 2. This all comes out to be negative 3, and that went down here. And then last but not least, we'll go row 1, but column 2. So we'll refer to row 1 on our first matrix here, and column 2 on our second matrix. So we say 1 times 4 is 4, plus 0 times 0 is 0, plus row 1, so 3, times column 2 times 1, so 3, and we get 7. Okay, and so this always kind of works out like this. Hey, again, by the way, if you tried to do b times a here, we'd say is undefined. We couldn't do it. Okay, so hopefully this helps with matrix multiplication.